Hello. In this video, we're going to look at solving right triangle problems, and that starts with actually the idea of solving a triangle. So solving a triangle means finding the lengths of all missing sides and finding the measure of all the missing or unknown angles. So let's start here with triangle ABC. So we know that angle C is 90 degrees. So I'm going to put C here. A is 25 degrees. The other corner must be B because it's triangle ABC. And side B is 3 centimeters. So remember that side B has to be opposite to angle B. And then the other sides will be lowercase a and lowercase c. So what we have here are 3 unknown values. We know the measures of 2 angles and the length of one side. We're missing the measures of 2 sides and the measure of one angle. In this case, the easiest one to find will be the measure of angle B, because we know that all the angles in a triangle have to add up to 180. Since one of them is 90, the other 2 have to add up to 90. So angle B is going to be 90 degrees minus 25 degrees. So in other words, angle B has to be 65 degrees. So that right there is one of our measures figured out. To figure out the missing sides, well, we know the Pythagorean theorem. I could use the Pythagorean theorem to find one side if I knew 2 sides. So I'm going to have to find one of these sides first using a trigonometric ratio. So I'm going to start by finding side A. Side A, it is opposite to the angle that I was given right from the start. Now, I know angle B and angle A, so I could use the fact that A is adjacent to B. But I'm going to use the fact that it's opposite to A because A was a given value. I know I haven't made any mistakes calculating it. So whenever possible, I'm going to use given values instead of calculated values. In this case, it really wouldn't matter because I'm very confident of the 65 degrees, and 65 is not a rounded value. But in cases where I've had to use rounded values or where I may be less confident in my answer, it just makes sense to use the given number. So because A is opposite to 25, and the side I know is adjacent to the 25, so we've got opposite and adjacent, that is going to be tangent. So the tangent of 25 degrees is equal to A divided by 3, which means that if I multiply 3 times the tangent of 25 degrees, that should give me the measure of angle A. So I enter that into my calculator, 3 times the tangent of 25, making sure that my calculator is not in radian, which is the default for many calculators. Make sure your calculator is in degree mode. So what I get here when I multiply this is about 1.3989, etc., for A. If I round that to 3 significant digits, it's kind of a weird rounding situation, but it rounds to 1.40 centimeters. That's approximately what A is. So 1.40 centimeters. A quick check on reasonability of the answer. This side is shorter than the other side. So 1.4 is shorter than 3. This leg is shorter than the other leg, which makes sense because it is opposite to a smaller angle. So angle 25 degrees is smaller than 65 degrees. So the side opposite should be smaller than the side opposite the 65 degrees. The hypotenuse will be the longest side because it is opposite to the biggest angle. So right now my answers are reasonable. I do just want to make a comment. If I switch my calculator into radian mode and I do this calculation, this exact same calculation, I would have received negative 0.400, etc. So getting a negative value is a pretty solid indication that something has gone wrong. And one of the things that sometimes goes wrong in trigonometric problems is that your calculator is in the wrong mode. So that's a troubleshooting thing that is helpful to know. So now, in order to find C, I could use something like sine or cosine. So for example, I could say that the cosine of 25 degrees equals 3 over c, which would mean, now if I multiply this out, I get c times the cosine of 25 degrees equals 3. So that means c equals 3 divided by the cosine of 25 degrees. This is how I can find c using only given values instead of calculated values. So 3 divided by the cosine of 25 gives me about 3.31 when I round it to 3 significant digits. And that is logical because we have the longest side now being C. Alternatively, I can use the Pythagorean theorem. So I can use the fact that a squared plus 3 squared equals c squared. If I do that, I should remember to use the unrounded value. So when I multiply 3 times tan 25, I rounded it to 1.40, but I had way more decimal places than that. So in my calculator, what I will do is I will square that unrounded value, add that to 3 squared, and then take the square root of that answer, which would give me exactly the same thing that I got by using the cosine, the 3.31. So the more things you know, the more options you start to have. Often when you're solving a triangle, you won't have very many choices for the first thing to calculate, but once you've calculated that first thing, the rest of them become a little easier. All right, so let's go with another right triangle. This time we know that angle C is 90 degrees again. So C is 90 degrees. A, B, C. I know that side A measures 9 meters and side C measures 41 meters. So this time I am missing one side and I'm missing both acute angles. Well, I can find that one side first using the Pythagorean theorem. So b squared plus 9 squared equals 41 squared, which when we solve this means b squared equals 41 squared minus 9 squared, and 41 squared minus 9 squared is 1600. So when we take the square root of that, we get b equals 40 meters. So that is all the sides now known. In order to find one of the acute angles, I'm going to need to choose to start with either A or B. Let's start with A. And because I know all three sides, and actually all three sides are exact values, I didn't have to round anything, these are all known whole numbers, I can use either sine, cosine, or tangent. I'm going to use sine because sine of A is the opposite side, which is 9, divided by the hypotenuse, which is 41, both of which were the values I was given right from the get-go. So the sine of A equals 9 over 41, which means that A is the arcsine of 9 over 41. Or another way to write this is sine to the power of -1. This does not mean 1 over sine. It means the inverse sine. It means undue sine. So on my calculator, I'm going to do the inverse sine, so -1 arcsine of 9 divided by 41, which gives me approximately 12.7 degrees when I round it to 3 significant digits. So about 12.7 degrees in here. That's angle A. To find angle B, I could use a cosine or sine or tangent again. That will give me the answer, but the most logical thing to do here is to say that angle B is 90 minus angle A. So 90 minus that 12.7. Again, in my calculator, though, I'm not going to round that value. I'm going to do 90 minus answer so that I get as close as possible without rounding before the final result. 77.3 degrees is what I get for B. So that's angle B. Make sure if you have multiple parts of your answer that it's very clear what those multiple parts are. So that could be going back to the triangle as I've done and writing the measurements into the triangle, or putting a circle or a square around your answers. Again, quick check of reasonability. Is the largest angle opposite to the largest side? Is the smallest angle opposite to the smallest side? Yes. So this triangle is reasonable. And finally, we can have contextual problems. So let's say at a particular time of day, we have an 8-meter tall tree. So tree. It has a 3-meter long shadow. We're going to assume this tree is perpendicular to the ground. The shadow of the tree is along the ground. So this is an 8-meter tall tree. This is its shadow, which is 3 meters long. What is the angle of elevation of the sun at that moment? So what that means is if you were on the ground here and looking up at the sun, what would be the angle you would have to essentially raise your eyes, assuming your eyes are right on the ground? What would be the angle you have to look up in order to look at the sun? So what we're looking for is this angle right here, which I'm going to call theta. So I'm looking to know theta. The sides that I know, so the hypotenuse that I've drawn in here is actually just kind of a hypothetical line. It's not a real line that exists. It's more like the rays of the sun as they come down. So I don't need to know its length. I don't know its length. It doesn't really matter. In order to find this angle, I have the opposite side and I have the adjacent side, which means I'm dealing with tangent. Tangent of theta equals 8 over 3. So theta is the arctangent, or tan negative 1, the inverse tangent, of 8/3. So in my calculator, I do arctangent of 8/3, and we get that theta is approximately 69.4 degrees. There we have